Hi again. This lecture will introduce refactoring, and while this is not debugging per se, it does relate to program implementation, or in other words, how can I get my code or my program to do what I want it to do, and once it does work, that is without errors, logic or otherwise, how can I then improve the design to be more maintainable or efficient? So code refactoring you can think of as the systematic process of improving the design or efficiency of the program without altering or changing its behavior. So we have these three phases in something called test-driven development, and we start off in the red phase, and this is basically where we write a test, which is some feature implementation. So let's say you write a function that takes in user input, so you go and implement that. You do some input, let's say into the console window, and let's say your function is supposed to return the greatest value out of 10. Let's say you have some table that has 10 values in it, or maybe you have to enter 10 values into the console. Alright, and that function returns the greatest value. Now if it fails, then you are basically in the red. So this is what typically happens. You have some feature that you have to implement in a program, and you work in a direction to implement that feature, typically a function, or in module 1 and 2 as you'll see, you'll start writing classes and so on. And it's often the case that the first time you go and do a test case, so when you actually have some code implemented and you run a test on that to see if it works, that it won't do what you want it to do the first time you test it. So it doesn't necessarily have to be a compile error or a warning. It can be a logic error too. In other words, once again, the program simply does not do what the programmer intended. So errors will guide you to the correct implementation, whether you have to use temporary output statements or whatever the case might be to see what is going on in your code. Of course, you'll fix compiler errors first, and then you'll work from there to see why does my program not give me the results that I expect, right? So that is typically the first step or the first phase. Then the next phase is the green phase. This is where you have the code at a stage where it works. So the code you write passes the test in that case. So in other words, the function or the feature works as expected, but the code might be ugly. So you might have a lot of code in the main function, for example, or in whatever the parent function is, or you might have repeated code that you'll have to go and encapsulate. We'll talk about that in the next slide. But the point is it works. It passes that initial test of it does what the programmer intended. Next comes the refactor phase. This is where we go and improve the code quality or efficiency. And we do this for many reasons, but an important one is for maintainability. We want our code to be maintainable because a lot of development time and resources goes towards the maintainability of code or towards the maintenance of existing code. And typically once you are done with these phases, you'll go and start at the red phase again. You'll write the next feature or the next function. That may fail, so then you may be in the red again. You try and solve the problems. So what logic or other errors you might have, you get it to work right as intended, and then you go and refactor that. So you encapsulate repeated chunks of code into functions and so on. So a bit more detail maybe on refactoring here. Let's say you have repeated pieces of similar or identical sections of code, right? That can become difficult to maintain. So for example, if a change to a variable name or a value is required, your code may require multiple changes, one for each repeated section of code. So let's say you have two variables that basically represent the same thing and you have to go and change both of those from 8 to 10, for example. It would be much easier if you had that set as a default argument to a function, so then you can change it in one place instead of having to look at, scroll through maybe a huge file of code to make those changes, because the repeated sections may be all over the place and it may be difficult to keep track of where those repeated sections of code are, right? So I've talked about encapsulation before, and a typical example of encapsulation is when we encapsulate similar or identical sections of code into functions. So the process of encapsulating similar or identical sections of code is essentially refactoring, right? Referred to as refactoring. And typically once that code is refactored and you want to go and make changes later on for whatever reason, it is typically much easier to then make changes or to maintain or to update that code, because once again it's not all over the place. Your functions are much cleaner. For example, if you have a lot of functionality or code in the main function and you encapsulate that code in the main function into another function, the amount of code in your main function is now much less. So you only have one function call, for example, instead of 10 or 20 lines of code. Okay, so next in Visual Studio we'll take a quick look at a basic example of what I mean by this. Here is a quick demo for you. I just have this silly game. It's not really even a game, I'll just build and run that. You see we get welcome to game over, you cannot win this game. Then it says game over again, enter Y to play again. Then you can enter either lowercase or uppercase Y. Press enter return. And if you enter anything other than Y, then it will end off with this message. Thanks for playing game over, please play again. You'll notice that I have all of this code in main, and this is a really simple program, but once it gets more complex, then of course main will be huge. So you want to start breaking things up. We'll start up here with these two lines. Right click on it, and you have quick actions and refactoring, similar to what we have here with surround with. You can go to quick actions and refactoring, and then you can extract a function. I'll click on that. I'll select above current function, so it's just going to be a void function. I'll click OK, and this is what we get. I'll just close off of that preview window. I would like to note that if you use this functionality, Visual Studio might go ahead and create a header file, and it will also include that at the top. So it might be best at this point to just go and type those functions out manually. And you can actually remove the header include as well if this happens, and you'll see that your program will run fine. Once again, we'll talk about headers in Module 102 in more detail, but I still wanted to show you the helper here. We'll talk about more of these helpers in Module 102 as well. So it creates the function up here, welcome message, and it's going to replace those lines with this here, the function call welcome message. Okay, before I do this here, I'll go and extract this down here into a function once more. I'll call that end game message, and I'll place that above the current function and click OK. Exit out of that. And then finally I'll do the game loop. So I'll select that, right click, quick actions and refactoring, extract function. Call that the game loop above current function and click OK. Again, this is just going to be a preview window, but since it is in the same document and the document is very short, I don't care about it too much. This will become more useful in the upcoming modules once we start working with multiple files. Okay, so what can we see here? We have the welcome message, the game loop, and the end game message. And you'll notice that the main function is much shorter now. Of course, we have more lines of code overall in the program, mainly because of the opening and closing brackets and these headers of these functions. Of course, if you have the declarations up here of these functions and you have the definitions down here, so after main, as we discussed previously, maybe with lines of comments as well, then your lines of code will increase, but still your main function is cleaner, it's organized. So here we see welcome message. What does this do? Well, we can just go to that function up here and we can see what it does. And in this case, we don't have repeated lines of code. We just have more code in a particular function that we would like. And we realize that we can clean that particular function up, break some of the functionality out into their own functions. So we won't do that only when you have repeated code. In my experience, for the most part, you will be doing it in this way. So when you have code that you would like to break up, or where you have functionality such as here, where you can break it up into a function called game loop, for example, or the welcome message, this might be multiple lines, right? So just a way of cleaning up our main function. Right now in game engines, you'll have various functions such as begin play, for example. So when your game starts or your level starts, but typically when the game starts, you'll do a lot of stuff and you don't want one huge function, right, with many lines of code that you have to like scroll through. You want to break it up so it's easy to follow and that is very clean. That's a major goal of refactoring. Alright, I'll build and run this and you will see this works fine. You'll notice that you can actually clean this up a bit more. So the welcome message, I'll cut that out. I'll go to the game loop and I'll paste the welcome message in there. I'll go and cut out that function call as well and paste it right at the end. So after that do while, paste it right here. So once we break out of this do while, then we go and do the endgame message. You can right click on here. Then once again you can pick definition. You can see the functionality right here, so you don't have to go and scroll to it. You can also right click on it and then go to the definition. So another shortcut, and you will notice the shortcuts in here. So go to definition, go to declaration. Right, so we have the welcome message and the endgame message in the game loop now. And then in the main, we only have the game loop function call. Build and run that. Right, and that works fine. Just a quick silly demo just to demonstrate to you the basic refactoring and a few other handy helpers in Visual Studio. Alright, I hope this section was useful to you, and I'll see you in the next video.